For the second part of 4.2, we're going to be doing this assignment 57 through 61. That's all of them. That's really not very many. And 81 through 84. So here's what we have to be able to do. We have to be able to answer a lot of questions about each function. And some of them are going to be familiar because we did them with our parabolas in the last section. And some of them are a little bit different. So let's start with the x and y intercepts. We did this last section and we're going to do it the same way we did it before. So if I go to my first example here, we get one of the intercepts by plugging 0 in and seeing what we get out. So I plugged a 0 in, 0 squared times 0 minus 3. Well, that's 0 times negative 3, which is 0. I plugged 0 in, I got 0 out. That's my y-intercept, and there's always only one of them. My x-intercepts come from all the things that are multiplied. So this one, if it was 0, it would equal 0. And for this one, if it was 3, it would equal 0. So that gives us, if it was 0, it would equal 0. If it was 3, it would equal 0. So there's my two x-intercepts because they get the number in the x spot. So here's my x-intercepts. And about those x-intercepts, I'm supposed to be able to answer, do they cross the axis or touch the axis? So I'll show you a picture of what that looks like real quick. If we look here, this crosses the axis at 0, crosses at 1, and crosses at 2. It crosses at 0, but at 1, do you see that it touches, it goes up, and then comes back down, and it crosses at 2. So this is a touch, this is a cross. Down here, here's a cross, here's a touch, because it goes down and turns back around and goes up, and then it crosses at 2. So that's what they're asking us about. What would the graph look like? And all we use to tell that, this part is really easy, the power. So do you see that this had a power of 2? Because that power is even, it touches. It's going to go down and back up. That's what an even power does. It turns itself back around. Because this is an odd power, x minus 3 to the first, because that's an odd power, it's going to cross. As long as it's odd, it will cross. As long as it's even, it will touch. So we just look at the power on it. What power function will it resemble? This is the same thing we have done in the past on the beginning of this section. So if we look up here, we just see what power would the x be to if we multiplied all that out. The x squared times the x would give us x to the third. So there's our power function. How many turning points would it have? It's going to have one less than its power. So because we chose x to the third, this is 2. So it's just 1 less than 3 is 2, and that's where it comes from. So I've got a couple more right here. Here's our new function. If I plug 0 in, I get 0 out. Again, negative 4 times 0 times 2. The 0 in there makes everything turn 0. So I plugged 0 in, I got 0 out. Then I go up and I see what would make the whole function equal 0. Well, 0 would. That's this part. And it has a power of 2. So 0, 0 has an even power, so that's a touch. Negative 2 would also make this whole thing turn 0. Negative 2, 0 is going to cross. That's an odd power. Do you see there's that to the first? So that's an odd power. It's going to cross. What power function will it resemble? Well, multiply all your x's. X to the second times 1 more x is x to the third, and that's 2 turning points because 1 less than 3 is 2. All right, over here, if I plug 0 in, this time it's a little bit different, and I thought it was good that we see one of these. If you plug 0 in, you get negative 1 times negative 2 times 4, which comes out to 8. So plug 0 in, you get 8. That's your y-intercept this time. For our x-intercepts, we go up here and see what would turn the whole function into 0. So 1, 2, or negative 4 would turn that bit into 0. So 1, 0, 2, 0, and negative 4, 0. They all cross because each one is to the first power, and that's odd, and odd powers cross. All right, then what power function will it resemble? Well, x times x times x is once again x to the third, and 1 less than 3 is 2, so that's how many turning points it will have. All right, last one of my examples. This one, if we plug in 0, 1/2 times 0 to the third times 0 plus 4, you get 0. because 1/2 times 0 times 4 is still 0. So there's my y-intercept. For my x-intercepts, 0 and -4. Because that 0 had a power of 3, that's odd, it's going to cross. This had a power of 1, that's odd, it's going to cross again. Crossing is more common. But if we multiplied all our x's out this time, x to the 3rd times x would give us x to the 4th. So that's the power function we expect it to remember. And it will have 3 turning points. In the next section, you use all that information to look at those graphs and tell which equation could go with this graph. So you can start just by looking at where the zeros are going to be. This is going to have a 0 at 0, 1, and 2. So this could be the graph of this thing. However, there's one more major point to look at, and I put it right here. If it begins with a plus, it's going to end positive. If it begins with a minus, it's going to end pointing down. This function at its very end, over on the far right, ends pointing up. So it can't be this. And it can't be f. Because our function at the very end, remember we read that graph left to right, it ends pointing up. So it must start with a positive. So it's one of those. But I also know it has to have points at 0, 1, and 2. So 0, 1, and 2. Maybe it's this one. But that right there, that's going to be a touch, not a cross, because of the even power. So not that one. All right, 0, 1, and 2. It starts with a positive, so that means it's going to end going up. So this one could be that graph. Here, 0, 1, and 2, but these should both be a touch because of the even power. So it is not that one. Notice that it says you might get more than one answer. So you need to check them all. We already said this one can't be it because it starts with a negative, which means it should end up pointing down like this one. See how that one ends pointing down? So its equation is going to start with a negative. All right, 0, 1, and 2. Odd power, odd power, odd power. So maybe it could be that one. So what we're going to do is check what we know, check the touching and the crossing, check those zeros, check how many turning points it has, and see if that could be the function that you're looking for. Again, it says you could have more than one, and then you're just going to check each of those 4 for all those potential things. We expect a touch at the 1, so our x minus 1 should have an even power. So we've narrowed it down to those 4. It ends positive, so our function better start positive. So we've narrowed it down now. It can't be this last one anymore. It'd have to be one of those 3 with our even and also starting with a positive. It has 1, 2, 3 turning points. You can think of the turning points as like little humps. That's where it changes direction. So its overall power should be a 4. Because remember, if its power is a 4, it has 3 turning points, 1 less. So this one has 1, 2, 3, 4. It could be that one. Just go through, check each one. Look at this one. It has an even power on that 2, but it crosses that 2. So it can't be this one. So go through your choices, all the information you have learned about all of the crossing and the touching and where it crosses and where it touches, and see if you can figure out which equation matches that graph. And raise your hand with questions because your class is taking a test today.